Welcome to Spring Lib.
You have a canal lock. What is so special about canal lock? Canal lock, in a canal lock, the amount of water stays the same. Now, if you have a ship with a lot of iron in it, let's say, now the amount of water displaced by the ship, which is equal to this volume, will that volume will correspond to the weight of the cargo, the iron, plus the weight of the ship, obviously. Now, what happens if the cargo is thrown overboard? The cargo simply sinks. Now the ship, the buoyant force simply it simply supports its own weight. So the amount of water displaced will only correspond to weight of the ship. So obviously, the amount of water displaced has reduced by that of the weight of cargo. So the water level will reduce, the height of the water will reduce corresponding to the amount of water corresponding to the weight of the cargo. Now, how much volume is that? Is that volume greater than the volume of the cargo itself? That is the question. Now, if the weight of the cargo is like some W, then it will be equal to the mass of the cargo times G, which will be equal to the volume of the cargo. Let's call it small b, times the density of iron times G. Now this will be equal to the water displaced, which will be that water displaced volume V, capital V, times the density of water times G. Now, if you notice, we can cancel G. This is an equal to. Now, the density of iron is much larger than the density of water, which means the volume of cargo must be much smaller than the density of water, which means the water level will rise because now the volume of the cargo has to be, the cargo has been submerged and it displaces water, but the amount of water displaced when it was in the ship was much larger than the increase in the volume due to the volume of the cargo itself, which is why the total water level will decrease in the second, will be smaller in the second case. That is, the total water level will decrease when you go from the first scenario